Okay, part 5, marker color brown. Here we go. Now we are getting into the fun stuff. Well, I mean, all math is fun, but like, this stuff is cool. So, now the true fun begins. We have thought through what a differential equation is and how to visualize solutions, and now we are going to actually start solving them, okay? So there's a ton of different types of differential equations, some of which require different techniques to solve. However, for the scope of this class, we will primarily be focusing on the simplest form of a differential equation, and these are separable differential equations. So we are learning how to solve right now separable differential equations. Quick sidebar. So remember from our previous chapter, integration. When we integrate, when we take an indefinite integral, our solution has plus c, right? Because it's plus some constant, right? And that's called the general solution, because plus c represents any and all constants in the entire world, right? But when we're given an integration problem that goes through a specific point, like it says find the integral of like x squared in terms of x through the point 0, 1. When we're given something like that, we integrate and then we're able to solve for c, right? So we would get like x cubed over 3 plus c, y equals x cubed plus over 3 plus c, and then we can plug in these values and solve for c, and that brings us to what we call the particular solution. So the same concept applies to differential equations. We're able to find a general solution first that will involve our good old constant of integration, and then if they give us a specific point that it goes through, then we are able to plug stuff back in and solve for c to get a particular solution. So that is just a fun little sidebar there. So here are the general steps to solve a separable differential equation. And if you don't take away anything from this video, take away this, because I literally still remember these steps from when I was in high school taking calculus and learning how to solve differential equations, which I then learned how to solve like 3 more times, but this is the method that stuck with me. So if I was looking at all of you, I'm looking at a bunch of empty chairs, but I'm scanning the room, I would make sure your eyes are on me. This is the steps for solving separable differential equations. Separate, integrate, evaluate, celebrate. That's it. 4 simple steps, okay? So I'm going to go into those a little bit, and then on the next page we'll do an example and actually solve a differential equation. You'll be like, oh my god, cool. But for now, okay, so, oh wait, before I get into the steps, note that not all differential equations are separable, okay? So this solution method will not always work, okay? Because those 4 easy steps that I just listed out for you only work for separable differential equations. Not all equations are separable, and so therefore the solution method will not always work. But you should always try, because it's like the easiest way to solve. Because again, we're gonna get into it. So this is like a great method. Very simple, easy to remember, 4 easy steps. Separate, integrate, evaluate, celebrate. Okay, but here's a breakdown of the steps. So step 1 is separate. This just means that we want all the y's on dy's, y's and dy's on one side of the equation, and all the x's and dx's on the other side of the equation, okay? So that means that we're going to use a little bit of algebra, hashtag it's just algebra 2020, trending, to rearrange our equation, okay? So that's step 1. Step 2, integrate. What was the point of step 1, you might be wondering? Well, now we're just gonna draw our integrand. No. Is there a name for this guy? I'll give you a point of extra credit if you email me what this is called. I don't know if it even has a name, but if someone email, there you go, extra credit point right there. Hopefully you're watching the videos. Okay, so step 2 is to integrate. Step 3 is to evaluate our integrals. Okay, which we should also be pros at by this point. Old news, integration. We just spent like five weeks on it. A lot of integration. And step 4, celebrate. We celebrate that we have solved our differential equation, and remember that celebrate starts with C, and we can't can't forget to add plus c to our equation. Okay, so that's what the celebrate step for. Celebrate plus c. I don't know if this is the right way for you. Hopefully you get the point. Okay, so now let's actually see these steps in action. I'm going to write them up real quick. Separate. Integrate. Evaluate. Celebrate. And I'm going to put a smiley face by the celebrate because we're excited. Woohoo! Differential equations, math. What fun. Oh my gosh, I'm going to trip on my computer cord. All right, so consider the differential equation dy over dx is equal to negative x over ye to the x squared. Okay? And we want to solve this differential equation. So step one, separate. We want to get the y's and dy's on one side and the x's and dx's on one side. So again, using hashtag it's just algebra 2020, we're just going to multiply the dx up like that. And now we have some x's and dx's on one side. But now we want to get this y with the dy. So again, we're just going to do some hashtag it's just algebra 2020, get that y over there. And so now our expression is going to be y times dy is equal to negative x over e to the x squared dx. That is step one. I'll write it over here. One, separate. Okay, step two is to integrate. Okay, so we have a variable that matches the variable of integration, so we're good to go. Variable that matches the variable of integration, good to go. That is literally as easy as step two. Bam. Now step three, evaluate. We're going to evaluate these integrals. So the integral of y is going to be y squared over 2 plus c. So 3 and 4 kind of go hand in hand. It's like if you're not in the perfect habit yet of writing plus c every time you take an integral, then it's like a friendly reminder. So if you remember plus c, then step 4 can legitimately be like, woohoo, celebrate. And if you don't remember, you could also, the step 4 celebrate could be like, oh, celebrate c plus c, okay? And then over here, let's do this integral over here, because we're going to have to do a little u sub, right? So we have the integral of negative x over e to the x squared dx. So I'm going to pull out this negative right here. So I'm going to have negative integral of x. And then I'm going to rewrite e to the x squared as e to the negative x squared, right? Exponent rules, woohoo, dx. Okay, so now I'm going to let u equal negative x squared. So du, the derivative of that is going to be negative 2x dx. And then dx is going to equal du over negative 2x. Rewrite this expression. I'm going to have negative integral of x times e to the u times dx, which is equal to du over negative 2x. Conveniently, our x's are going to go ahead and cancel. And then I have this 1 over negative 2, so that's a negative 1/2 that I'm going to pull out. And then when I multiply negative 1/2 by the negative 1 that's already out here, I'm just going to be left with positive 1/2 times the integral of e to the u du. The magic of e is that the integral of e to the u is e to the u. So I'm going to have 1/2 e to the u plus c. Woohoo, celebrate, plus c. And then I'm going to replace, I know that u is actually negative x squared, so my solution is 1/2 e to the negative x squared plus c. So, equals 1/2 e to the negative x squared plus c. And then let's go ahead and call this c1 for constant 1 and constant 2. Because again, these are just general plus c's. They represent any and all constants because they're from our integrals, just like we learned in integration. So recall that the solution to a differential equation is a function, right? So like a y equals. So to put this in, this is the solution, but we're going to put it in a more explicit y equals form, okay? So to do that, let's multiply up this 2. So I'm going to have y squared plus c1 is equal to e to the negative x squared, because 1/2 times 2, plus 2c2, but 2 times any and all constants. Remember, that plus c just kind of like absorbs it, so it's going to be just plus c2 still. Let's go ahead and subtract this c1 over. But again, c1, c2, they represent any and all constants. We can add or subtract as much as we need to, so that c2, positive c2 minus c1, that's just going to end up as a plus c. Okay, so we're going to have y squared equals e to the negative x squared plus c. So again, this is kind of a weird concept, but remember that when we integrate and we get this plus c, it's representing any and all constants. So it doesn't matter what we add to it, doesn't matter what we subtract to it, doesn't matter if we multiply by 2. It's still just going to be any and all constants. Okay, so that is why we're able to do that. That's kind of a weird idea. So if it's taking you a second to like kind of think through, that's totally fine. Again, just kind of a weird thing, but yeah. All right, and then we want to solve for y. So to solve for y, we are going to take the square root of this guy, and we are going to end up with y equals plus or minus, which everyone always forgets about, the square root of e to the negative x squared plus c. And there, my friends, is the solution to your very first differential equation. On the next page, page 9, there is more practice with general solutions to differential equations. And again, they have the answers right at the bottom, so if that's not what you're getting, try to go ahead and do it one more time, zoom into tutorial. Yeah, anything you want, really. Remember your 4 steps. And there is more practice. I highly recommend doing these again, cough, open note quiz. There are more examples on the homework, the differential equations worksheet 1, 2, which you are to complete as homework. And then, yeah, I will make another video about practice with particular solutions and practice with particular solutions to differential equations, pages 10 and 11 of the note packet, because I think this video is getting kind of long. But separable differential equations, super easy. 4 easy steps. You got this.